Welcome to our webinar, Open Software Defined Automation Part 4, Digital Continuity. This webinar is sponsored by Schneider Electric and Automation.com. Automation.com is the media and information subsidiary of the International Society of Automation. My name is Renee Bassett, and I will be your host. Today we are exploring the value of digital continuity, a core pillar of Open Software Defined Automation, or SDA. We're talking with Andre Babineau, SDA Country Director for Schneider Electric, and Sean Gregerson, Vice President with AVEVA. You'll learn how Schneider Electric's EcoStruxure automation expert integrates with AVEVA industrial software to enable seamless data interchange for industrial system design, control, and operations. This is the fourth in our series of webinars with Schneider Electric on open SDA strategies and benefits. After our discussion, we'll allow you to ask questions of our distinguished panelists and provide links to our previous discussions. Use the questions icon to submit your questions at any time. They'll only be seen by me and our presenters. We'll answer as many as we can while we keep the overall presentation time to 1 hour. Before we dive into the topic, I'd like to have our guests introduce themselves and give some background on their companies and their experience. Andre, welcome. Let's start with you.
Thank you, Renee, and thank you. I'm glad to be here again, sharing our view on open software-defined automation and the whole ecosystem that it represents. So I'm currently the country director for open software-defined automation in Canada. But prior to that, I was part of the organization that defined the requirements for Schneider Electric. Where do we want to go, and what does it mean, software-defined automation? I'm really a strong believer that automation today requires a different new approach to the traditional approach of hardware-centric vendor lock-in. It is great for the supplier to have this lock-in, but quite horrible for the end user when they hit this brick wall of obsolescence.
Sean, why don't you introduce yourself?
Sure, Renee. I'm Vice President of Asset Performance Management and MES for AVEVA. And if you're not familiar with AVEVA, we are Schneider Electric, wholly owned industrial software company. And a bit about myself, I've spent largely the last 20 plus years in industrial data intelligence and robotics and the use of AI to drive operational efficiency and productivity improvements in industrial manufacturing.
Excellent. Welcome. Glad to have you here today. So the reason why we're talking today is because of the profound challenges facing industrial companies and how digital transformation in general and software-defined automation tools specifically can help address those challenges. Gentlemen, can you tell us about the challenges and opportunities you see facing your customers? Andre, let's start with you.
Yeah, certainly. As stated in the introduction, the industry currently is totally fragmented, and it is the customer and the end user that are paying the price for this fragmentation and not having access to portable, interoperable, cybersecure solution. Open software-defined automation is really poised to address each of these problems. Yes, suppliers are now saying they're interoperable because they have implemented a few standard communication protocol on their platform, allowing them to communicate with others. But I can tell you the problem is way deeper than this. Without a clear direction to make the solution portable, the end user will remain at the mercy of this closed ecosystem. Schneider Electric is the vendor that has created and donated the necessary software to universalautomation.org, or in short, UAO. And UAO has this mandate to make portable software in automation a reality. Universalautomation.org is an independent, nonprofit organization that can provide the runtime to any vendor, end user, and academics for their own use and product development. So Schneider Electric is really committed to provide an open software-defined automation solution based on the UAO.org solution. So the customer has now the freedom to choose the hardware platform and the right software to prevent the end user to hit this hardware and software obsolescence that we talked about. It is important to note that most solutions today has proprietary software that runs on bespoke hardware. So obsolescence hits both hardware and software in most of the cases. And this is where the industry is today after automating their plan for the last 10, 15, 20, 30 years. They're hitting a place where everything needs to change, not only from the hardware and software from their supplier, But also the most critical aspect is the IP in which they invested in the last 20, 30 years to make it perfect for automation and control. So Schneider Electric is committed to remove this hardware and software lock that force customers to massively invest in their automation system. It is good also to think that disruption that exists with the obsolescent brick walls is the loss of data, as I just mentioned. So this is how I see where the challenges are today. And I'm sure Sean has differently some key aspect to help our customer also to leverage this data.
Yeah, Sean, why don't you give us your perspective from the industrial software side of things?
Sure. What we see is a really key problem across industrial manufacturing and critical infrastructure is really that many have these silos, these data connectivity silos, these stakeholder silos, these functional and divisional silos that exist across the design, build, operate, maintain, and optimize asset lifecycle or value chain. And what this is really preventing is it's preventing people from having access to the information that they need to make timely and informed and optimized decisions for the business. And along with this, it's often preventing the ability to progress from a digital transformation and in digital maturity perspective. And the cause of this is often rooted in getting trapped by point level software solutions. So, what we've tried to do and spend a lot of time really perfecting is to create this sort of continuation that extends across that entire design, build, operate, optimize asset lifecycle, this digital thread that enables our customers to operate in a more effective, more productive way.
I see. And that's the basis of our topic here today. We would like to explore some of that digital thread and that concept of digital continuity. Can you give me a definition of what that means and how it relates to the challenges that you described?
Definitely, I can go ahead and try to pinpoint what it is, at least from a Schneider Electric perspective. When we define the solution, our EcoStruxure automation expert, which is an open software defined automation solution, there were three major principles to respect. We needed to continuously have the hardware independence in mind. We had a digital continuity concept and what we call the asset centricity or the application centricity. So the other two we've covered, but today we're going to focus on this digital continuity. So what does it mean and why is it so important? Digital continuity is probably one of the main challenge that any digital transformation project is facing. Data is key, and data today is heterogeneous and really hard to put in one common environment. Also, it misses most of the time the contextualization that is key to be able to run deep analytics on any of this information. So data needs to be portable and readily readable and available for any software to have access to the data and the context. So when we define the requirements of EcoStruxure Automation Expert, we ensure that we can be fully agnostic to any of this hardware and be able to exchange with any of these different software to make sure we can read and basically respect the data and the conceptualization and bring it to a level where it can basically start being used and really start to draw the value out of that data. E was also designed to reduce the time it takes to develop engineering and all the configuration that is required. And we've done this through digital continuity. So how can we leverage all this design data that exists today from the different, I would say, engineering, procurement, and construction team that developed this solution, and how do we bring it directly to our little piece of automation and configuration? So we created bridge between those two worlds, leveraging AVEVA solution and AVEVA engineering have a multiple solution where basically now natively we can exchange data bidirectionally to make sure that we manage this data across the design and the implementation. And that saves humongous amount of time versus trying to transfer tables as we know in the past, sending Excel sheet there, it's not correct, going back and forth. So we're trying to minimize this exchange of data by working on the same type of data directly with our customer. The other thing that is key for Schneider Electric is our promotion to openness. We have designed EcoStruxure Automation Expert around standard to make sure that it can be applied to anyone and communicate with any solution. And we do leverage universalautomation.org. So just to conclude, let me try to give you a few analogies just to try to understand what digital continuity can mean in other contexts of a automation solution. You can think about it, and that's something we see often in the United Nations. You got all the different countries that are represented, but basically they all have their earpiece to make sure there's a translator talking to them, but not necessarily hearing the data or the real life data directly from whoever is communicating today. So imagine now this same world without any translator. So whoever talks can understand each other, even though they're not necessarily talking the same language, but there's a mean to get this translated automatically somehow. Right. So that's one way to think about it. But also you can think about when we used to use paper map, and paper map is always obsolete because there's always change in the road. But today with our connectivity with any of the map tools that we have in our phone and in the car, all of these changes are directly communicated by the users. And if there's a change on the road, or there's construction, or there's even policemen on the road, we're being notified. This continuity of data makes any travel a lot safer and a lot easier. So these are the kind of example that exists in different contexts of automation that really provide the value of that digital continuity. And that's exactly what we're trying to replicate in the automation and trying to be successful. So this is really what digital continuity is about.
Sean, is there anything you'd like to add in terms of digital continuity from the industrial software side?
Sure. No, I think Andre did a really great job of it. I would just add that in order to leverage these new AI technologies that we have available to us today in the industrial domain, it really requires this liberation and unification of the industrial data. You've got to create this unified ontology and taxonomy that's describing the relationships that exist across all the different domains and dimensions of the industrial data, effectively relating a asset on a P&ID drawing to these specific historian tags or attributes to this asset ID in a ERP or EAM system. And these standards that we have available to us play a key role in accelerating the unification of this industrial data and also in its longer term governance. And at AVEVA, we're very much standards driven. We're supporting many of the industrial standards that are used in industry today. CFOS is a common one from an engineering design perspective, and ISO 14224, which is defining the structure of reliability and maintenance data, and literally hundreds of IIoT standards like OPC-UA and MQTT. And so I'd say this digital continuity comes from this unification and governance and security of the industrial data, and standards are playing a big role in this.
Excellent. Is there anything more we can say, getting a little bit specific about automation expert, excuse me, EcoStruxure automation expert, and how it's enhanced within Viva software? So, how does digital continuity come into play when the two are used together?
Absolutely. And there's definitely a great link there. So for EcoStruxure automation expert, Schneider Electric paid attention to the different phase of any automation solution. If we start at the design phase, we have created interface with a Viva engineering tool set. And we developed tool like there's one example I have in mind is what we call the PNID scanner that basically leverage again open standard like DexP to be able to extract the data out of those PNID and generate the necessary control database and also the operating graphics or representation of those assets that we find on the PNID. So yes, we do start by leveraging AVEVA engineering toolset and we continue to expand it in the automation because this is all design data that we directly import and start configuring without losing any data along the way in any context because these are the design data. So really this is a key element at the engineering phase to give us as an example. But obviously at operation, as Sean was mentioning, we do leverage Aviva Historian and also seamless integration to Pi. We have connector that allows us to feed the data directly to Pi without any specific configuration from the user. So all these different specific elements just make the life of our end user a lot easier. And we know automation systems become more and more complex. So what we're trying to do is remove the complexity out of those systems by leveraging digital continuity along the life cycle of the project. The other aspect that we look at is the operation. Obviously, operation need to be trained in any new system. So operator training simulation is the key element that we do leverage, and we do have a key interface. And also the other place where we start integrating even more when the customer requires them is the advanced process control. When the customer wants to optimize their solution and really extract the maximum out of their plant and their process, we do have direct connectors with those solutions to make sure that we can again use that digital continuity from design to operation to maintenance. So AVEVA has an extended software suite that Sean can certainly explain more than I can because it's a large inventory of solution, but we do have specific already integrated point between Schneider Electric open software defined solution and AVEVA.
Great. Anything you'd like to add, Sean?
Sure, yeah. I mean, just extending into the Aviva solutions, we've spent the last 50 plus years getting really good at industrial data management and operations control and manufacturing execution and helping our customers to digitally construct their capex projects. It's important to note, Aviva, we're not an AI company. We're a data intelligence and industrial software company, but we've always infused the latest AI capabilities that we have available to us today into our products. And the first application that we infused AI into was over 20 years ago, and we've continued to iterate that technology, adding the latest, updating it for the latest, greatest AI capabilities available in industry and replatforming that technology is still part of Aviva's active software portfolio. But what we're doing is leveraging all of the latest AI technologies that we have available to us today in industry, and then we're infusing these capabilities into our industrial software applications and platform so that our customers can take advantage of all these new capabilities, but in the industrial context. And we've been able to create this very modern Connect platform. And the Connect platform is effectively bringing together all of the operational data, typically through our edge capabilities or our a Pi system that Andre mentioned. And it's taking in this information, it's organizing, it's contextualizing it. We're running analytics against it. And then we have this other capability that's fusing together all the domains and dimensions of the industrial data across that asset lifecycle. So the design information with the operations information, with the asset management information, with all of the optimization related information together. And it's unifying this through this intelligent industrial knowledge graph and then making this information searchable through more more traditional search type capabilities with Google type search capabilities, but also with these new generative AI search capabilities that we have available to us today. And then we've got these domain specific applications that are pre-integrated to this platform that just plug in and provide these domain specific outcomes, whether that be predictive maintenance, leveraging AI and machine learning for early warning detection, diagnosis of equipment health and performance related issues and driving to fault diagnostics, prescriptive guidance, and prognostic information, or the use of simulation software to drive the process and the assets to the highest levels of performance and productivity. And then we have this unified visualization layer that's sort of encapsulating all of these applications, all the data within these applications into this single pane of glass so that this information can be accessed in context. And everything that we're doing, it's open, it's agnostic, it's built to integrate with the existing hardware and software infrastructures that our customers have already invested in. And all of this Connect capability is built on this foundation of AI and data governance and security.
I understand. And I'd like to hear some more specific use cases so we can really understand the benefit and how it works in the real world. I know you have a couple to share with our listeners today. Who would like to go first in giving us some specific customer examples of how this works?
Sure, I'm happy to go first if that works. Great. So a good example would be Wood. They're a highly successful EPC. They use Aviva's unified engineering software to digitally construct their customers' CapEx projects. And in one of their projects, they're able to discover a pretty significant issue at the time of design before they progressed to the build construction phase. And in this case, through this early identification of this issue, they're able to identify over $1 billion in savings just from this single issue that they were able to correct at the time of design through these digitally constructed approaches. And they're digitally constructing their customers' projects, effectively creating this digital twin or this digital model at the time of design. And this really speeds the EPC to owner operator handover. And it's providing their customers with this digital model that's fully ready to be used to drive operational efficiencies and gains through a operations digital twin. In another example I could share would be Saudi Aramco, where they had AVEVA's Pi system in place for many years, and they had lots of data, but they wanted to be able to translate this data into more information and more outcomes for the business. And so they put in that other capability to fuse together the industrial data, the engineering data, and operations data, and asset management related data, and then put in this unified visualization layer so that they can have these visualizations at the corporate level, drilling down into regional level views and site level views and unit level and even asset level views and how their assets are performing. And then they plugged in to this information digital twin these different value enablers, starting with the predictive analytics capabilities. So leveraging artificial intelligence and machine learning for early warning detection and diagnosis of equipment reliability issues, and then plugged in Aviva's process simulation software, which is using first principle physics-based modeling to drive these assets to the highest levels of performance and productivity. And then what they're doing is using what we call hybrid AI modeling. So they're taking the output of this physics, first principle physics-based model as soft sensor inputs to the AI machine learning models to further enhance and enrich and provide a higher fidelity model of the asset in the process in the end.
Excellent. Andre, do you have a case study to share with us?
Yeah, maybe have an example without naming necessarily the customer is on the lifecycle management and the system evolution. As we know, and we talked about this, is the customer at one point run into this brick wall where basically both the software and the hardware become obsolete. And then there's a massive cost to replace that existing hardware and software. And basically, this company went and trying to get approval to do the replacement. And basically, their board said, why would I do this? Because you're going to come back in 20 years and do the same thing again. This is just repetitive and we cannot continue to do that forever. So basically, they needed to find a solution which is going to allow them to basically remove that brick wall. So basically, be able to replace both software and hardware at any given time to make sure they never reach this obsolescence, which is extremely costly because not only you need to replace your control system, but also you need probably to change all this IP you developed through the years because this IP that you developed is probably not compatible with the new hardware and software you're going to have. So, what basically with our open software defined automation we're providing to the customer is now a platform on which they can continuously evolve and never become obsolete on their IP. It's a little bit an example that we give in prior webinar here is the example of the music industry when streaming came about, right? You may have created a playlist 10 years ago that you still listen on the new phone you just got, but you probably changed 3 or 4 times already this phone, but you can still listen to the same playlist. And that's really what we mean. You keep your IP the way you want it, regardless of the hardware platform that you find below. So this is a key example where basically it enabled now the customer to go and provide and be do the replacement as they see fit, and not only we're doing this for the future, but it can do that, I would say, online in the sense they don't need to take a shutdown or stop the machine, stop the process to be able to change hardware or software. So basically, as we know also today, there's a lot of requirements on cybersecurity that is continuously changing, and you have no choice to keep your system protected that to upload or change those patches to make sure your system is still cyber secure. And just to mention, our solution, EcoStruxure Automation Expert, is the only open software defined platform that is approved by TUV 262443 SL2. So these are examples that I have to show what are the values we can bring to the customer through that digital continuity as well.
Well, we have been talking about how open software defined automation and this digital continuity does enable sort of longer term planning. And as you say, Andre, being able to upgrade on the fly, if you will, for whatever you need. And Sean, the examples you gave with regard to adding some of those advanced capabilities are things that many of our listeners are trying to do today. The ultimate goal for many, the future state, if you will, is building towards autonomous operations and being able to have systems that sort of fix themselves as they go and operate without a lot of human intervention. Can each of you tell me how software defined automation, from your perspective, and digital continuity enables that leap to autonomous operations? Andre, could we start with you?
All right. Certainly, definitely. So, yes, autonomous operation is a key. And it's interesting that you mention it because that was kind of the ultimate goal that we put ahead of ourselves when we designed EcoStruxure Automation Expert. So, all the different features that we looked at, we were trying to always find a way how does that help to go towards autonomy for the system. So, we've delivered technology and we have delivered technology today to the system and system management solution that helps the customer simplify a little bit the maintenance of his system. So imagine a controller failure at 3 a.m. a Saturday morning. Obviously, no one wants to go to the plant and start searching for the problem, trying to find to a replace unit if possible. And it takes time and it's complicated. Today, we can offer to our customers solution that basically will remove that problem if you want within 2 minutes without any human intervention. And that's also the key here is without human intervention. As we know, there is a workforce challenge that we're facing in automation. So it's harder and harder to find resources that join automation team and be able to maintain those systems. So basically we're bringing solution to the customer that basically alleviate this deep knowledge of the system. So the system takes care more and more of itself, bringing a certain level of autonomy. So that's one way we look at it. But obviously, there's a lot more we can do. The other piece is basically talking with AVEVA and digital continuity is look how do we leverage those digital twin to make sure that how we can validate performance or drive higher performance depending on certain process condition, feed, quality, things like this that we can basically simulate before it hits the plant and see what's the best settings. All of this brings another level of autonomy, but more on the operation side. So basically, we're working on multiple level to make sure that we can bring higher level of autonomy to the customer and basically extend the useful life also of the plant and the investment they.
Sean, can you tell us from the industrial software side? I mean, Andre covered some of the ongoing operations, but definitely the integration of AI and digital twins and these advanced capabilities seems like an important aspect of getting us to autonomous operations.
Yeah, for sure. AI has a really big role to play here, and from an AI perspective, we've had this really fast progression from generative AI to agentic AI to AI agents. But the foundation of these technologies is rooted in pervasive access to highly contextualized and organized data. And it requires this liberation of the industrial data and breaking down the silos. And the path to autonomous operations is definitely a journey, but a journey that many of our customers have already started on and significantly progressing on with many of these new technologies that we have available to us today with drones and robotics and in AI. A good example of this is the Abu Dhabi National Oil Company, ADNOC, where they've defined their autonomous operation strategy for their business and named this Neuron 5. And AVEVA's technology is playing a foundational role in this. It's bringing together and unifying and organizing the industrial data and using AI and physics-based simulation and monitoring technologies, these AI agents that are autonomously discovering reliability and performance issues and providing guidance on what action should be taken towards remediation of these issues and to drive the production assets in this case to the highest levels of reliability in performance and productivity.
Excellent. I have learned a lot about the importance of digital continuity and offer open software defined automation solutions today. And want to be able to allow our audience to ask you some questions as well. But before we transition to those questions from our audience, could each of you tell me something about the roadmap for migrating to these modern systems and what services each of your companies provides, divisions provide to help users make the moves? Andre, let's start with you.
Yeah, definitely. That's a great question. And basically, as we discussed a little bit already in the collaboration with AVEVA, we already embed a tool set that allows to make this seamless integration to make sure we get this digital continuity. We use a tool that's called Asset Link. We talked a little bit about how we use this P&ID scanner. So we leverage different pieces like this already. But to make sure that you can go do this transition, which is a little bit of a change to transform from traditional automation system to open software defined automation solution, we do have a team of experts that basically collaborate with you directly. And the best thing I say is reach out to us or to your local rep to see how we can demonstrate to you today some example and how we can help you do that transition, even with your current solution. It's not because you have a solution, but that you have in place that we cannot come and help you. We do a lot of these things where there's a heterogeneous system, and we use open software defined automation to start building this digital continuity on top of your existing, to start be able to share the data and then provide you with a roadmap of the future of how you can continuously upgrade and move toward a more software defined solution. So this is basically the approach. So I definitely encourage you to reach out to your local Schneider or Aviva representative to make sure that we help you, guide you to a more digital continuity future.
Sean, how about you from the Aviva side?
Sure, I would start with our Connect platform is really enabling our customers to define a digital vision and strategy for their business, and it's doing this in this highly modularized way so that customers can enable or just plug in these different domain-specific capabilities, and then effectively enabling them to progress sort of at their own pace and in their own way on their digital transformation and in their digital maturity. And a large part of the roadmap is enabling customers to solve these net new use cases that drive operational efficiency and ultimately the profitability of their business. And in doing this, as you can imagine, a big part of our continued roadmap and development is infusing and leveraging these new AI technologies to ensure that our customers can take advantage of these latest innovations in industry, but in the context of the industrial specificity within which they operate. And along with this, we're helping our customers to progress on this journey, providing digital workshops and sharing of best practices on how other leaders in industry have been able to achieve these gains for their business. And really together developing digital roadmaps and visions and helping our customers to then successfully implement, adopt these new digital technologies in new ways of working, these new, more efficient and effective ways of working.
Well, thank you both very much. I really appreciate your time today and that we got a chance to talk.
Thank you, Renee. It was a
Thank you.
pleasure.
Appreciate it,
And
Renee.
thank you, Sean.
Now,
Thanks, Andrea.
let me set up our system so we can answer our questions from our audience. So, just a moment. Welcome, gentlemen. Thank you so much. Thank you so much for this excellent presentation. And we have gotten a number of questions in from our audience. And I would like to remind our audience to give us more, because we will get to as many as we can at the top of the hour here. And then anything we don't get to, we will be answering via email. So please continue to have those questions come into us. I also want to let our listeners know that we have a handout available for additional information. So let me just, if you go to the top of the screen, the icon with the paperclip is handouts, and you will be able to see this slide deck that I'm showing here. And it has a number of links that you'll find quite useful. We have more information on a number of the topics mentioned today from both Schneider and AVEVA. And you also have links to all of the events in our webinar series on open software-defined automation. So download that and link to whatever you need. So let's get to those questions. The first one we have here is for Andre. And it's about the fact that many plants can't afford a full rip and replace of equipment. And it seems like we're talking about moving to more future ready systems. So can a customer begin their journey toward digital continuity by implementing open SDA in one small area of a plant while keeping their legacy DCS or PLCs in others? And how do AVEVA and Schneider Electric manage that hybrid data flow?
Oh, that's an excellent question, and it's absolutely real use case, because what we see today is really customer taking this step-by-step approach, and really this open software-defined automation allows you to do that. So let me explain a little bit what we mean by this. I think it's one of the key elements of open software-defined automation, like EcoStruxure Automation Expert. As we've defined earlier, EA is based on what we call digital continuity. So the platform support most of the existing protocol that are available in the market today, and then becomes quite easy to interface to any other vendors or even Schneider Electric solution of the past, and provide a unified view of all these alternative systems through EE and in a unified manner. So basically, you can use EE as become your collector of information if you want, and slowly moving those alternative systems one by one when times come. And as we're application centric, you develop your application of what you need, and then at the time you're ready, you replace the existing controller with a new controller, and then you just deploy this new application to this system. And now you're starting to create the homogeneity. But there is nothing that prevents you to go step by step in a small piece and then continue to add, because that application centricity allows you to see your plan holistically. And then if you have one application, you design it. You want to add another one, you just continue to design it. And when you're ready, you just deploy it. The other thing you can do with EcoStruxure Automation Expert is when you develop this solution, you can basically, within the tool, use a built-in simulator to test everything before you deploy. Obviously, we have a solution that we discussed with AVEVA, being an operating training simulator, and you have other type of simulation that you can use as well to make sure that whenever you're ready to deploy, everything works perfectly. So that's the other piece of integration with AVEVA that we can say. And the third piece I would say from an AVEVA perspective is when we start integrating all this information into a centralized area, it's quite easy to have the view with an integrated HMI from AVEVA, and also probably use an AVEVA historian to be able to collect all that information and make this data ready for any other solution to pick up and continue the analysis. And the last point I would make is, how do we make those things, the second part of your question, how do we make all these pieces working together? As we talked about, we have a tool within EcoStruxure Automation Expert called Asset Link, which really bridge from, I would say, your design tool that you have to your automation system, a continuous flow of information to make sure you don't have to retype and do things twice. So really bringing your engineering efficiency higher and making sure that your go-to-market is a lot shorter. So this, I think, answered a little bit the question.
Thank you. We have a couple of questions about AI, which I'm not surprised since it's such a hot topic these days. Let's start with one that looks like it's probably for Andre.
Okay. Looking
toward the future state, which you mentioned towards the end, how does having contextualized data from AE make it easier to actually implement industrial AI compared to just having a massive pile of raw data in a traditional historian?
Great question, because this is one of the biggest challenges that we hear for any digital transformation project today. It is data. And as you probably know, 80% of digital transformation type project doesn't necessarily meet their targeted objective, all due to data or bad data or not contextualized data. All of this data need to be a little bit more
curated before we can extract the value of that data through different AI type of tool and different type of analytics that we can bring on top. E, being agnostic to any of the data, can collect this data and contextualize it and making sure we use a central repository like we mentioned earlier on, like AVEVA Historian, and take all these heterogeneous source of data and then make it a seamless and homogeneous type of data that can easily be available to any other type of analytics application or any other application that we might have in a more digestible, data-ready solution. It could be an AVEVA solution or other vendors, but that data is a lot easier to consume when you already aggregate it from all these different heterogeneous type system and format into a consistent format. So it's a key element to use this agnostic, I would say, aggregator from legacy solution. And then also what we provide from an EcoStruxure automation expert is, yes, we do have all this type of legacy type protocol that exists in the market, but we also have the latest and greatest like MQTT and all the other modern protocol that also are typically integrated. So all of these, they come into one place, make it a lot easier to start adding to it with different types of AI application, making sure that data is fully contextualized and ready to be used. So this is how we can help this AI transition in the industrial world.
Great. Well, Sean, we had you're welcome to give me your thoughts on contextualized data, but I'm going to give you this other question that we had, and maybe you can weave it in after that as well. The question we had for you was, how do I get started with AI monitoring of industrial assets?
Sure. So I would say that it's an important point when you kind of get started with the predictive monitoring of industrial assets, to sort of decouple the technology, the AI, from the business problem that's being solved. And it's super important to start with the business problem that's being solved and what the goals and benefits to the business are of solving that problem. It can't be technology for technology's sake. And so often the way that we do this in working with our customers is we like to start with what their corporate objectives are, whether that's improve operational efficiency or maybe to reduce their OPEX or CAPEX cost structure, whatever it may be. And then what we do is work and define an asset strategy that's balancing the risk, cost, and performance aspects of the asset strategy best to meet those corporate objectives. And that's really important because you can have high levels of reliability, but often that can come with an unrealistic cost structure for the business. So you really need to be very deliberate in managing the risk, cost, and performance aspects of the asset strategy to align with those corporate objectives. And underneath that is the people, process, the technology, and the data that then supports that asset strategy that's been defined. And so it's identifying where are the places that we're seeing these reliability and performance improvements within the business. Let's identify what those critical assets are, and let's identify what the cost of those reliability and performance issues are within the business, and what is the value of solving those problems through the leveraging then of these AI capabilities that we have that can identify these issues weeks, months in advance of equipment failure, and then what the business impact is in solving that problem. And I would say that a key point is working with a vendor that doesn't just know AI, but understands the domain specificity and domain of the specificity of the problems that are being solved, and is able to combine that together with the technology. And just getting back to your earlier question, all of this to work, anything that we're doing from an AI perspective has to be built on a solid foundation of industrial data. The data needs to be unified, it needs to be contextualized, and you can really spend time solving that problem once, and you can do it in a very scaled way. Or every single AI project that you have, you're going to wind up having a data integration, a unification, contextualization aspect of the project, and it really slows you down from a digital transformation, digital maturity perspective. And as Andre was saying, one thing that can really speed this up is, with the EcoStruxure automation expert, it's really pushing this contextualization and unification down to that root layer. And when you do that, it really speeds up the ability to be able to accelerate at pace as you're starting to implement these AI applications within the business.
I see. Thank you. Regarding some of those specific solutions and where AI fits, there was a question about predictive analytics and how that differs from more traditional vibration monitoring solutions. How would you answer that, Sean?
Sure. I think if you just look at traditional alerts, and I think we, when you look in industry today, where you have alerts coming from your digital control system, from your SCADA systems, from vibration, often these are kind of a high, low type alert set point. And when those conditions exist, you need to take this sort of immediate step to remediate those types of issues. The idea with more of a predictive monitoring approach is it's using AI and machine learning. So it's not just univariate where it's looking at one variable and setting a high-low operational range for that particular sensor reading. But it's actually taking for this in this instance vibration in context with all the other variables within that are related to that asset, things like load, things like speed, things like the current operational state and condition of the asset. And by doing that, you're using this multivariate approach, which is effectively linking sensor A to B, B to C, A to C, so sensor to sensor comparisons in n-dimensional space. And that's how you're able to get these early warnings that are weeks and months in advance of equipment failure, is by building this learned model for each individual asset, in identifying the signature for how that asset operates, and then monitoring in real time to detect these very subtle deviations in its behavior. So this doesn't replace vibration monitoring by any means. It's really enhancing what you have from a vibration perspective by integrating the other process and sensor data around the asset with it.
I see. We had a question come in about alarm management. And the listener says, traditional alarm management focuses on rationalization and limits, but open automation and AI/ML introduce the possibility of dynamic, context-aware alarm and process behavior. How are Schneider Electric and AVEVA approaching next-generation alarm management, where alarms adapt based on operating mode, asset health, etc., while still maintaining governance, explainability, and operator trust in the digitally continuous environment?
Interesting question. Do you want to give us a stab at it, Sean? And I will sort of
Yeah, sure, absolutely. So, look, what I would say is we have spent a lot of time on optimization from a alert and events perspective. And when you start to implement this layer of online predictive asset health monitoring, it's precisely what's being asked in this question, where you are taking kind of this multivariate approach to the problem. So you're not just looking at each sensor and what the normal range of operation is for that sensor. We still can configure those types of rules within the DCS, because we need to know when we're operating outside those ranges, because it's safety issues, it's production issues, and so on. But by layering in this AI ML dynamic alerting perspective, what we're able to do is identify these issues before they show up as operational issues. And so we're significantly reducing the amount of operational alerts and alarms that we're getting that have to be acted upon, in many cases, instantaneously. And we're substituting that with these alerts that are detecting these problems, these future problems, weeks, months in advance, And so it gives us this additional time to really research these issues, driving to fault diagnostics, prescriptive guidance, prognostic information of how much time do we have until this asset's likely to fail, and having these capabilities to give us these prescriptive insights on what actions specifically we should take before these assets fail. And that is really supporting then operational excellence by being able to operate in a more controlled way, because you're dealing with a lot of these issues before they become operational issues that need to be dealt with immediately.
Great, and let me try to tie this a little bit what we're doing with EcoStruxure Automation Expert from an alarm perspective, but mostly more from a philosophy, I would say. And just to take some of the word that have been used in the question, basically where alarms adapts based on operating mode, asset health, and process intent. So really kind of, these are really kind of discrete states. So first, one thing we need to recognize with EcoStruxure Automation Expert, it's really we're asset-based. It's not a type-based system, a little bit we deal with AVEVA, which is really from an asset perspective and not a type-based system anymore. So that's the first approach, is we're looking at an asset, not on a type-per-type basis. So that's the first approach that's really aligned to the question here. But also when we talk about operating mode and process intent, this is trying to describe a little bit another feature that you can easily implement in EcoStruxure Automation Expert is state-based control. So you define the state, being event-driven, and makes it quite easy to adjust based on the state you're looking for. For example, you might decide that you want to operate at minimum energy consumption or maximum throughput. And basically being a state logic, what we have with EcoStruxure Automation Expert, it might quite easy to change from one state to other because it's all aligned to those states. And yes, alarms is part of those states and need to be adapted. So really, when you start looking at state-based control, that's really, you need to look at it holistically. A little bit like Sean was saying, you need to adapt, but that's really now you adapt to the states and everything adapts accordingly. So I think both combined solutions together, it really provides this new view of what alarm can be and how do we need to work with our customer to change to this vision of being state-based control and really start defining those states and the right alarm that goes with it.
Great, thank you very much. We got another question that asks you to be, can you take an actual use case as an example and explain how open software-defined automation helped achieve the objectives in a way that couldn't be solved by more traditional PLC, SCADA, or DCS systems? What does open software-defined automation bring to the table?
Mm-hmm. Mm-hmm. And I think one of the examples is really what I just mentioned about state-based control, mm-hmm. where an operation wanted to really be able to go, and it was not the exact state I defined like minimum energy, maximum throughput, but they have specific state they wanted to reach. And by using EcoStruxure Automation Expert, they were able to do that quite simply on their own because they did understand the state-based logic that they had. And then it was easy to transfer to state-based control, a more holistic view. When they wanted to change, it was easy to change the state machine to the state they wanted. So instead of having complex type sequencing to start changing different things, it was a real simple process for them to be able to do it on their own. As we know, state-based control was something that exists and been existing for a long time, but it was not as easy to implement. Now it's just the ease of use and the alignment of EcoStruxure Automation Expert really allowed them to go through it fairly easily compared to a traditional solution. So that's where I would use one of those examples.
Great, thank you. Well, we're getting close to time, but I definitely don't want to leave our discussion today without talking about cybersecurity. And we did get a question that said, you said that EAE is the only open software-defined automation platform approved by TÜV to 62443 SL2. In an open software-defined world where we're using Linux and Docker containers, how do you maintain that level of security without experiencing the, quote, security by obscurity that proprietary systems used to rely on?
Yeah, that's an excellent question. So I'll try to shine some light around it. Obviously, there's a lot of technical details, as you can imagine, with anything that requires to be cyber secure. But really, EcoStruxure automation expert has really I would say, the advantage over any solution that's on the market today for the last 10, 15 years, wherever they were developed. It's a brand new solution. So by design, in its first step of design, it was all considered with all the cybersecurity modern concern that we see and live in today. So really, the platform is by design intrinsically cybersecure. What it means is each transaction that we see within the ecosystem of Automation Expert is cybersecurity. And it needs to be designed to make sure that you meet the level of security you're looking for. Where if you compare to the design we used to have with all the different solutions, whatever vendors, it was not designed like this, right? It was an afterthought when cybersecurity and cybersecurity threat became a problem into the OT space. It took a little bit longer than 90, but it finally reached us. And then people needed to start protecting their critical infrastructure. So what happened at the time, without being able to change the overall infrastructure that OT existed, what we've done is basically put barriers around the system. So preventing penetration into the solution. So really is kind of a shield around the solution where each transaction has already its own shield. So we can protect a lot deeper and leveraging some standard technology as we've seen and heard before, being Linux or Docker or any other way, to be cyber secure. And that's really what makes a difference with any other solution in the market. Even though it's software design, it really makes sure that each of those transactions and exchange are cyber secure. So that's really the big difference between what we're used to be and where we're going, how we can make your system even more cybersecure than ever been before.
Sean, what would you like us to know about AVEVA's perspective when it comes to cybersecurity these days?
Yeah, so from an AVEVA perspective, it's really building off of this zero trust security model that we have, and it's just the decades of experience that we have in how to really bridge the OT with the IT world from a security perspective, and building that into our software applications. And we're using the latest around AES 256-bit encryption and all the latest technologies that are available in the industry to secure these systems for our customers.
Thank you. Well, I want to be mindful of time today, so I will say that's all the time we have. If there were any other questions that came in from our listeners, they'll be answered via email. But I want to thank our listeners for being with us today. And I want to thank you, Sean, for providing AVEVA's perspective, especially on the topic of integrating AI into industrial systems. I've been happy to have you.
Thanks, Renee.
Thank you. Thank you, Renee. And thank you, Sean.
And Andre, I appreciate you being with us throughout our 4-part series on open software-defined automation. And I encourage our listeners to go listen to the other segments to learn more about this important technology going forward.
Absolutely. It was a pleasure, Renee. Thank you very much.
This concludes our presentation for today.